This is part of our Guide to Grafana 101 series. This is actually the first webinar in a series of 3 technical sessions that we're going to be doing. So you're actually the first to know that this is not the last one out there. Some quick introductions about me before we delve into the technical content. So my name is Avthar. I'm from South Africa. I'm super interested in how to use technology to empower people. That's why I really enjoy my job as a developer advocate here at Timescale. And I also learn new things on a daily basis in this profession. And so I write about it on Twitter and on my website, avthar.com. So if you want to follow me, you can do so at those places. And in today's session, we're going to do 4 things. But before I outline them, I just want to remind everyone that this is an interactive session. So please feel free to ask questions using the Q&A feature in Zoom. So there's 2 different buttons, one for Q&A, one for chat. You can just chat in the chat if you'd like to. But if you want to ask a question, please use the Q&A feature, and our technical team of dashboarding and Grafana experts are on hand to answer them at the end of today's session. And just also a quick reminder that you'll receive a recording of today's session afterwards, along with links to code, the slide deck that I'm using, and other helpful resources. So don't worry if you can't take notes or you happen to miss something. You can always go back and check it out later. Okay, so in today's session, we're going to do 4 things. The first one is chat a little bit about why use Grafana and just why I like Grafana for those who are new to Grafana and Timescale. Secondly, I'll do some orientation and setup where I'll show you how to connect to a data source and just quickly orient everyone. I realize and everyone is coming in with different levels of experiences and familiarity. So I want to orient everyone in part 2 and then get straight to the best part, which is creating the visuals. So in the third part of today's session, we're going to create 6 visualizations together that you can use. And I'll be doing that in 3 common use cases, namely DevOps, IoT, and public data. And that's getting you excited for what the bulk of today's session is going to be about. And then in the part 4, I'm going to leave you with some resources for how you can apply what we're going to be talking about to your own work and answer your questions. So please do use the Q&A feature when you have a question. Okay, so let's get straight into part 1, which is why use Grafana. So I realize, as I mentioned, some folks may be familiar with Grafana already, but for those who aren't, this is just a quick refresher so we're all on the same page. Grafana is an open source visualization tool. It's really great for monitoring, but it's also useful as a general purpose visualization tool, as I'm going to show you with some of the other use cases and data sets that I'll demo today. You'll probably recognize it from its really distinctive UI. It's got this nice dark theme going on. And you can see that in the screenshot. And from my experience, there's a couple of really great reasons to use Grafana just from talking to people using Grafana at Timescale users, and in my own experience building dashboards for various projects that I'm doing here. The first one is that it's open source, so it's cheaper than having a proprietary tool, or at least it's a cheaper alternative. The second one is that it's really great because it has a lot of support for many different types of visualizations. I'm going to show you in today's session how we can make a variety of different things to show, to sort of demonstrate and convey the information that you want, and you're not restricted to just having a graph or a pie chart or something like that. And it also has support for alerting, which is something we're going to cover in a future webinar. The last thing is that it has support for many different data sources. So things like Postgres, Prometheus, AWS CloudWatch, all the things that we use in our workflow as engineers, whether it's in monitoring or just general databases, there's support for that. And you can also combine data from multiple different places in one dashboard. And I'd also like to hear from you if you just want to type in the chat, what do you use Grafana for? What's your use case? What sort of reason and what kind of data are you visualizing in there, just so that maybe I can tie in some examples as I go through the content today. Okay, one thing though is that if you have used Grafana before, you probably know it can be really tricky at first. There's so many features, and you might not know when or how or why to use different things. You know, there's things like graphs and stats and gauges and world maps. So it's quite a lot of features, and we might not know how to make the best of it. So today I'm gonna actually take you through creating 6 common visualizations that you'll need for dashboards in a variety of different use cases. And I'm gonna illustrate that with 3 different data sets, as I mentioned: DevOps, IoT, and geospatial data, and the last one just being a public data set. And I'll also leave you with some docs and tutorials that you can follow, and you can actually customize them afterwards to get started really quickly. Okay, so that brings us to the second part, which is around orientation and setup of a data source. In this section, I'm gonna quickly take you through a basic mental model for thinking about Grafana. This is, again, this will be a refresher for those of you already using Grafana. We'll cover dashboards, panels, and data sources, and I'll walk you through how to set up a data source for timescale, since that's something that you probably wanna do if you're using timescale. Okay, so a good way to think about how Grafana works is that the most high-level unit in Grafana is the instance. So you can have one or more Grafana instances, and these can either be in the cloud or on your local machine. Now, each instance houses multiple dashboards. So the dashboard is usually something that you build for a specific purpose. So you might have a dashboard for monitoring a certain product or a certain deployment. These are sort of the units of sharing in Grafana, where you have a dashboard that houses many visuals. These individual visuals are called panels. So dashboards are comprised of panels, which are individual visuals, so things like graphs and gauges and maps. And these visuals can actually be powered by one or more data sources. So here's some examples of the data sources that I'm going to be using in today's demo. These are all timescale databases, unsurprisingly, but they house a variety of different things. And the other good thing about Grafana is that in the dashboards, you can have a dashboard connected to multiple different data sources. And in this case, what I have is I've got several different panels connected to different data sources, as you can see here by the color coding that I have going on here. And this is just a toy example that I put together for today's webinar. You know, I've got a gauge going on here from a monitoring data set. I've got a graph showing COVID cases and another graph showing buses. So it's a mishmash of things. But what I want to illustrate to you is that this actually translates to being a really good tool for doing custom dashboarding for stakeholders looking at a variety of data sources. So say, for example, you want to have a dashboard that gives you an overview of multiple products in your company. They all have data in different databases and coming from different places. You can actually build a dashboard that shows you that data all in one place. The same goes for if you're in a role that requires you to look at data from a variety of different parts of the organization, maybe like a CTO, you're looking at data from DevOps and products and sales, you can just have that all in one dashboard from a variety of different data sources. Okay, so that's a quick overview. If that was too fast for anyone, please do ask questions in the Q&A panel or the Q&A thing in Zoom. And now we're gonna get into the first demo of the day, which is how do you connect a timescale data source in Grafana. Okay, so let me exit out of this presentation and open my Grafana instance. So I've got a hosted Grafana instance going on here. And what I'm gonna do is show you how to set up a new timescale data source. So I'm gonna go to set it, configuration, and click on data sources and add data source. Now, for those of you who are new to timescale, timescale is a open source, scalable time series database built on top of Postgres. So what I'm gonna do is select a Postgres data source. Also, if you're new to timescale, welcome to the timescale community. That's a good introduction to timescale and the various benefits that you can get from it as powering visuals. So I've got this new Postgres data source set up, and I'm going to call it TaxiDB, so you can give it a name. In this case, it's going to have data from taxis, that I'm going to use in the demo later on. And in this case, I'm going to find all of these just database information. Because my database is actually also hosted in the cloud, I am just going to pop over to my Timescale Cloud overview and take all the information and copy and paste it into the right places. So I've got a host, and then I also need to put in the port number afterwards because there's no specific box here for the port. So that's a pro tip to be aware of is, you've got to put in the host and your port number. Database name is called default DB. So I'm going to copy that in there. So, if you're using Postgres, there's a variety of defaults for these. If you're using a hosted Timescale instance or just a hosted database instance, you'll find these in your overview panels. And a password is going to be the secret password right here. So it's super simple to connect a data source to Grafana. The SSL is require. Okay. And then I'm going to leave these connection limits default for now. And then one thing to note when you're connecting a Timescale instance is you want to select the latest version of Postgres possible. So I'm going to choose 10. And then you want to enable TimescaleDB here. And if I click the help button, it tells me that, TimescaleDB is a time series database on top of Postgres. And if you enable this feature, it will use timescale functions under the hood in Grafana. So in this case, Grafana will use time bucket in the time group macro and display TimescaleDB specific aggregate functions in the query builder. So basically what that means is that you will actually run timescales optimized SQL in order to make your dashboards run a bit faster or much faster in many cases. Okay, so we're gonna save and test. And when you get the green, that shows you that connection is okay. So we've successfully set up a timescale data source in Grafana. This is how you can set up many different data sources. In this case, it's a Postgres database, but also applies to other data sources. And now that we've got this basic mental model for how Grafana works and we've seen how data sources works, let's get into the next section, which is the main portion of today's section, building 6 awesome visualizations. Quick reminder, if you have any questions, please use a Q&A feature in Zoom, and we'll answer your questions at the end of today's session. Okay, so in today's demo, we're gonna use 3 different data sets to, one, demonstrate the versatility of using Grafana for this variety of different use cases. So the first one we're gonna use is a DevOps data set. So this is monitoring a production database using Prometheus. The second one is an IoT data set, and it also has geospatial data, a geospatial component in it. And that's monitoring the live locations of buses in New York City, which is where Timescale is headquartered. Well, everyone is at home right now, but that's where our office was. And the third one is a public data set, which is monitoring the COVID-19 spread in the USA coming from the New York Times. So I've just used a variety of different data sets to show you that you can, whatever you're working on doesn't have to be monitoring. You can use Grafana for it. And I've chosen these data sets and these visuals that I'm going to show you because these are the things that I've seen Timescale users use in their dashboards. And I'm also going to show you some tips and tricks I found useful in building dashboards. We're going to cover things like variables and series override. That's more pro tips for you if you already know the basics of Grafana. Okay, so getting to this first data set, just to give you a little bit about the data source and into the structure of the data that's going on. I'm going to focus more on building the visuals. If you have any questions on any of the SQL syntax and any of the structure of the data, please do ask. But that is covered very well in the resources section at the end of today's session, and you'll have links to that you can go and get your questions answered as well. But I just want to put that out there. Okay, so this data set, it comes from monitoring a timescale database using Prometheus. So what I've been doing is monitoring a database and then using Prometheus to scrape metrics from that database. So things like performance, disk usage, and like cache hits and things like that. And I'm storing those in Timescale. I'm using Timescale as a remote read and write for Prometheus. So what I'm going to build today is show you how to build these 4 different visuals. These range from basic to more complex. So the first one is just using a single statistic to show the timescale version that's running on the database that we're monitoring. The second one is a gauge to show the disk usage. We're going to build this gauge right here with the various thresholds and the numbers here. The third one is a graph to show the cache hit ratio going on in the database. This is more of a performance metric. And the third one is also going to be about the cache hit ratio, but I'm going to show you how to just use a single stat to display the latest cache hit ratio or the most current ratio if you don't want a historical time series like the previous one. Okay, so let's get into our Grafana instance here. And I'm going to go to my dashboards, and I created a blank dashboard for today's session. So the first thing that we're going to do is create the single stat for the timescale version. So what I'm going to do is add a panel and choose the single stat visualization. And single stats are really great if you just want to visualize like one number rather than visualizing a whole trend over time. And these are also good for things like version numbers or things that don't necessarily need historical context. So in this case, the database that I'm monitoring is the one that I just set up called TimescaleDB. So I'm going to select that as the data source for the query. And then I'm just going to have a SQL query that shows me the version of timescale that I'm using in this database. So here's the query that I'm using. It's just selecting the extension version from the PG extensions table where the extension name is TimescaleDB. Okay. So, and also another thing in this case, you want to format it as a table so that it doesn't expect. Grafana has all these constraints around, time series data. You got to have a time column and order by and group by. But in this case, we're just having a table. And so that gives me the number, but we can do a bit better in terms of actually modifying the visual. So in this case, you'd want something like this under the values section to have quite a large font size. So I'm putting 200% so I can see it. You can also put like prefixes and suffixes. So maybe, you can put timescale in front of it just so that we know this is the timescale version of it. I'm going to take that out since I'll probably put that in the title. But that's the types of things that you can do in order if you just want to display a single number. I'm going to give the panel a title and call it timescale version, and then description timescale version on TimescaleDB. And these are just best practices so that if someone else is looking at your dashboard and wondering what's going on, they have a description of what's actually happening. So I'm going to save here, and that's our first visual, just using a single stat to show the timescale version that I'm using on this dashboard. And it's actually can be pretty important because in this case, I'm using 1.4.2. It might be the case that certain features are only available on certain versions of the software that I'm using or certain versions of the database. So it's always good to keep in mind these types of things. This is something that you'd want to monitor about your database. Okay, so the next visual that we're going to do is a gauge to show the disk usage, as I mentioned. So we're going to build this gauge showing the percentage of disk usage. So let's do that. We're going to do new panel and choose the visualization as a gauge. So the first thing I'm going to do here is go and select my data source. So the data source that I'm going to use is called monitoring DB. This is where I have all my Prometheus metrics about the taxi database that I'm monitoring. And the gauge here is very nice for something like disk usage because you want to use a gauge when you want to know the latest value of something and you want to know whether it's within an acceptable range or not. So in this case, I want to know, is my disk getting full? Do I need to provision a new disk? Do I need to upgrade in my cloud database provider? So yeah, so that's why the gauge is super useful for stuff like this. And in this case, I've already selected monitoring DB as the data source. So what I'm going to do is just copy and paste a small SQL query in there that shows you that will get the disk usage. So what I've done in this query is, as I mentioned, in the database, there's Prometheus metrics being stored in the database. So I have a view called metrics, and that view, I'm selecting from it the time column, and I'm using the time group alias here to bucket these values in 1 minute buckets. I've actually set the scrape interval in my Prometheus to scrape every 10 seconds. So what we do, we're just getting 1 minute buckets from that. And I'm selecting the average value as the percentage of disk use from this metrics view. And then I've got this time filter macro in Grafana here, and then you specify the time column. This allows me to use this time filter at the top here in Grafana so that they know I don't have to rewrite SQL queries. I can just use the UI to change the time. And then here, I know that my metric name is called disk used percent. So I just say name like disk used percent, and that gives me the metric that I'm looking for. And then I'm grouping by and ordering by one, which can be a weird thing in Grafana for those of you who haven't seen it before. One is basically just the first thing you're selecting. So in this case, one is the time. So I'm grouping by and ordering by time. And this is actually pretty important in Grafana because group by and order by is necessary because Grafana just plots the points or plots the data in the order that it receives it. So if you don't group by and order by for your time series data, it might not necessarily be accurate. So this is just to ensure that I have my data in the order that I want it. And okay, so that's the query that I'm actually going to use. As I mentioned, Avia, for this time group alias, this is actually using Timescale's time bucket function under the hood to actually give us these aggregates of the disk usage in 1 minute intervals rather than 10-second intervals like they were originally scraped. Okay, now let's go into the modification of the visual. So in this case, I want to, under the display section, I want to show a calculation, but I don't want to show the mean. I want to show the last value that's being the last value in our data set. So this ensures that we're seeing the latest disk utilization. So it ensures you're reading the most recent value. And then what we're going to do is now make this gauge more useful. Right now, it's just all green. That doesn't really tell us much. So what I'm going to do is give it some thresholds in order to show the acceptable levels of disk usage. So what I'm going to do is, in this case, Grafana has this thresholds function, so we can associate a color with a certain range. So I'm going to say the green is the base one. I'm going to make the next one 50. I'm going to make the following one 75 and the following one 90. So I just did that by adding new threshold levels there. And in this case, I want the colors to sort of match the severity level. So I'm just changing the colors to green, yellow, orange, and red. And Grafana has this nice thing where, say, for example, I change this to 66, it'll automatically reorder the threshold values so that you don't have to reorder them yourself. But in this case, I'll change this back to 90. It keeps the same color, so I suppose it doesn't really know what each color means. In this case, I'm using it for like severity levels. So that's this. And in this case, I'm going to give my gauge a title of disk usage percent. And the unit that I'm going to choose is percent 0 to 100. And there you have it. So now that we've told Grafana, what units we're behaving in, it actually divides up this gauge according to the thresholds that we just set here. So I could change this and I could make this 60, and you can see the yellow part then becomes a little bit smaller. It basically just divides it up according to the thresholds that we've set over here. And I'm not going to mess with min and max. And another thing I'm going to do is enable the labels. So this actually gives you the values that you've divided up this gauge according to, so that, you know, people don't have to eye it, and you might not know, okay, I see this thing is yellow, but what does yellow actually mean? These labels are a good way to remove any confusion from that. One pet peeve of mine is that this text is a bit big. As you might notice, it doesn't really look that nice. So, you know, maybe hopefully Grafana can change that in the next iteration. Another thing I'm going to show you is, say, for example, my disk usage is at 25% right now. If I change the orange threshold to be like 15 or something, then currently I can see the color then changes to yellow. So that then tells me, you know, whether my current value, which threshold is actually fitting into. But in this case, I'm okay with the yellow being at 50. That's okay. So this is actually super useful because it'll tell you what, you know, whether or not you need to take action, whether things are in acceptable ranges or not. This is a simple example of disk usage, but you can use it for a variety of other things, for fixed resources that you need to understand the utilization of. So I'm just going to call that disk usage in TimescaleDB. And description, I'm just going to be lazy and use the same thing for the description. You probably want to give a more thorough explanation, but that's how you make a gauge and how you customize it to be useful to people who are reading it, especially if, you know, you're the person who's going to be reading the dashboard isn't the one who made it. Okay, so the next one we're going to go to is this graph of a cache hit ratio. So because I'm monitoring a database, I'm going to look for these kinds of metrics that are common in databases. One thing you want to know is this metric called the cache hit ratio, which is a ratio of blocks hit in the cache to the blocks that were actually had to be read from the database that weren't found in the cache. So in this case, I'm going to stick with the normal graph. This is the most common or the default visual in Grafana. And once again, I'm going to choose monitoring DB as my data source. Now, for this query, I'm actually going to show you that it's a more complex query because, you know, unlike the previous two, we're not just monitoring one metric. So I'm not just like selecting one Prometheus metric. I actually want to plot a ratio between two different metrics. So what I'm going to show you is just a generally useful pattern for graphing ratios in Grafana using SQL. And so in this case, as I mentioned, I'm doing the cache hit ratio. So let me show you the query that we're going to use, and then I'll explain it line by line. So in the comments over here, the cache hit ratio is basically this calculation that we're doing here. Let's wait for this to highlight, which is the sum of the blocks hit. So in this case, whenever I say hit, it means the number of disk blocks found already in the buffer such that a read was not needed. So this is in the cache, you know, a common computer science concept. And read is the disk blocks read by the database. So I've used these as aliases throughout the calculation just to make it a bit easier to understand. And so the key here is when you're plotting ratios, you want to do what's called an inner join to make sure that you're only, the inner join is in SQL is different from a regular join, because the inner join is basically taking the intersection of two sets. So basically what I'm saying here is I'm joining this metrics values table where I have times for both the hits and the reads. Because if you have time for one but not the other, this calculation that we're doing here that relies on both of them, both of their values, fails. So we want to take that intersection. That's really the secret to plotting these ratios in Grafana. So to take you through the rest of the query, basically what I'm doing here is selecting the time of the cache hits and then calculating the cache hit ratio, which is the value of the hits over the sum of the value of the hits and the value of the reads. So we want to take total hits plus reads and use that as the denominator, and I'm going to call that cache hit rate. And then what I'm doing is I'm querying this metrics values table, but I'm aliasing it as hit, and then I'm joining it on itself. So I'm joining it on metrics values again, but I'm aliasing this metrics values as reads, and I'm joining it on this time column such that I only want the values where we have values for hit and values for read. So as I said, we take an intersection, and then over here, we're selecting the label IDs. So each of these Prometheus metrics is associated with a label ID in my database. Beforehand, I went and found these are 312 and 314. 312 for hit, 314 for read. And then I'm grouping by the hit time, just because that's the first table that I'm querying from. And I'm also ordering by hit time. And so basically, once you've done that, you get this nice line graph that shows you the cache hit ratio. This shows you for the last 6 hours. If I do it for like the last 15 minutes, you can actually see this database, I'm not really querying it that much, so the ratio is fairly constant. You can also play around with things like having points on your graph that shows you where the actual data points were calculated at. And you can play around with things like the fill and things like fill gradient in order to make your graphs look a bit better, and things like line width in order to make sure that you can see the lines and the graph has accurate or acceptable usability in terms of like people being able to read it. So let me actually just put this line width back to 2 so that it's not too thick. And basically what I've just shown you here is this pattern for doing ratios in Grafana. There's nothing more that I'm going to modify on this graph. So I'm going to call this cache hit ratio for TimescaleDB. And again, I'm just going to use the same thing as the description and save it. Now, this is good if you want to look at how something has changed over time. But if you just want the latest value, I suppose you could, look at this graph and then look at where the last data point is and read it. But I want a single stat, or I just want a panel that tells me, what is the last value that I'm looking at in terms of my cache hit ratio. So that's where this next visual that we're going to create comes in, which is creating a cache hit ratio, but using a single stat. So this is a modification of the query that we used here. So what I'm going to do is just create a new panel, choose the single stat. So Grafana has that nice search, not singletons, single stat. Okay, single stat. And I'm actually just going to copy and paste the same query. So I have that in my scratch paper here. The data source that I'm going to use is called monitoring.db, and the query that I'm using is the exact same query. And in this case, what I'm going to do here is all the magic happens in this visualization part of the query editor. So we're going to keep the format as time series. You could put it as a table, I guess. And what we want to show is instead of selecting average, we select current. So this actually selects the last value that is being returned in the time series data that the data source returns. I'm going to make this font 200 again, so it's nice and big. And in this case, for percent, because it's a ratio, we for the unit, sorry, not percent. Because it's a ratio, we want to choose percentage between 0 and 1, because your ratios are always going to be between 0 and 1. And so in this case, because I've chosen that percent, it actually converts it now to say, okay, cache hit ratio most current 98.81%. I can change this, say if I want 5 decimal places for some reason, it'll give me 5 decimal places. You can play around with that. But what's also pretty cool is that you can use the same sort of thresholds trick that we did before in order to show whether this cache hit ratio is within an acceptable range. So for example, I then go and select background and I turn it on, and I might have a certain threshold over here that tells me that, okay, say for example, if my acceptable threshold is 0.95 and I have another one at 0.99, so there should be a comma here, comma 0.99. Then you can see, okay, this value that we're currently seeing at 0.98, it's not green, but it's not red either. So it's actually just orange because it falls in between those two values. In real life, you probably want to just keep something like 0.95. That's a fairly good threshold. This should change. And in this case, what I'm going to do is invert this, because currently what's happening is that because the thresholds function such that anything lower than 0.95 that I put here takes green, I want to invert this and such that we shouldn't really have three colors here. I'm just going to put another color here, 0.9. So we're going to make this 0.9 and 0.95, such that this 98% that I'm seeing here is actually a good, cache hit ratio that I'm seeing. And again, for the threshold values, these need to be in the units that your output is in. So I can't put something like 95 or 98. I have to put it between 0 and 1 because that's the unit that I've specified here. So that's small things to be aware of, things that might trip you up as you try and implement this yourself. I'm going to call this current cache hit ratio and current cache hit ratio for TimescaleDB. Okay, so that actually takes us to the end of the first part of today's demo, which is showing the how you can use these visualizations on a monitoring data set. This is actually, I've shown you a few different ways where, you might want to have a dashboard that focuses on, okay, show me the historical performance of my system, where you'd use a lot of these time series graphs, and you'd have a lot of things that may be roll-ups or aggregates. And then you might also want to have a dashboard that shows you the current real-time or latest version of what's going on in your systems, where you'd probably want to use things like gauges or single stats to just show you the latest numbers. So these are the tools that you can use to then create more complex dashboards. So now that we've done with the DevOps use case, the next two use cases are just going to have one visual each. So the next use case we're going to go into, or the next data set, is going to be the IoT one. And if you have any questions about what we just did, please use the Q&A feature in the chat. And if you have any questions about the DevOps one, we can answer them at the end of today's session. Okay, so in the IoT use case, what I'm actually looking at here is a geospatial data set that's monitoring the location of buses in New York City coming from the MTA. So the MTA is just the Metropolitan Transport Authority. They are the people who are in charge of buses in New York City and all public transport, actually. And I've got the data from them. And what I'm going to do is build a world map that shows me the live location of buses in New York City. And I'm going to show you how to use variables in Grafana. Where's my mouse? In order to show the different routes that the buses might be going on. So this is just, again, a toy example that I'm playing with here. But if you have an IoT fleet of devices, you might want to show the real-time status of them and also segment them by different types. So you can actually translate what I'm doing there onto your IoT use case. Okay, so now that I've dealt with that overview, let's actually build this visualization. So as I mentioned, we're going to use a world map. So I'm going to choose visual and then search world map panel. Okay, and then what I'm going to do is let's save the configuration, the configuring for later. And I'm going to select as a data source MTA bus DB. So that's just where I have my bus data in. And the query that I'm going to use, let me show it to you right now, is one that actually makes use of another Postgres extension that's called PostGIS. So let me make this red error go away, and then I'll explain why I did that just now. Okay. So in this query, what I'm doing is, so I'm using this thing called PostGIS, which is the geospatial extension for Postgres, and I'm using it alongside timescale. So what I have over here is both time series and geospatial data in the same database. That allows me to do things like what I'm doing right now, where I'm plotting location, but the latest time. So I want to know the current location of something. You can do these very powerful things when you use databases like timescale. Okay, so what I'm doing here is that I'm selecting the latest time that I've seen, that I have for the buses. So that's like the last time that I've had for these buses. The vehicle ID, it's just an ID associated with each bus, and something called the route ID. You can think of this as something that like segments the buses into different types. And then what I'm doing is that I'm creating this kind of like a placeholder variable in SQL, where I'm saying, okay, if the route ID starts with an M, then we're going to assign it 1. So this variable is actually going to be the color that the buses show up on the map. So if the bus ID, if the route ID starts with M, we're going to color it color number 1. If it starts with B, it's going to be color number 2, and Q is going to be 3, and S is 4. So M, B, Q, and S, these are just the different routes that they take. They stand for different regions in New York City, the different parts of the city. And that's going to be the thing that we alias as color. Then what I'm doing here, and those of you who have used PostGIS before will recognize it, I have this column called geom. This is just something that the PostGIS extension requires you to put your data in. And I'm isolating the X and Y values of that and calling that longitude and latitude respectively. And then, so I selected all those things, and I'm querying it from my empty database called MTA. And I'm selecting it where the time is greater than 1.5 minutes ago. So I want like the most recent data. And I'm going to group by the vehicle ID, the route ID, and this geom column. And then I want to order by 1, which, as you remember, is going to be the time. So again, this order by 1 in Grafana is very important because of the fact that you want your data to be in time order. Okay, so that's where the query ends. And the last step over here when you're using the world map with timescale and time series data is you want to format things as a table. And this is important because when we go into the visualization section, we want to tell Grafana, when we go to the map data options, that our result is in the format of a table. And the aggregation is going to be the current, because we're plotting the current location of the buses. Then we look at this very helpful message that Grafana shows us. So it basically tells us that we need to indicate to it how our data that's being outputted is being formatted. So the table query format that we use isn't in geohash, it's actually in coordinates because we call it latitude and longitude. And once you tell it, properly how your data is being formatted, you see something actually shows up on the map. Now we're going to actually zoom in and see what shows up just now, but I need to do a few more things in the configuration. So what I'm going to do is call the location field the route ID. This is the name of the location name column. It's used to label each circle on the map. Then the latitude and longitude fields are just the name of the latitude and longitude columns. We alias them latitude and longitude previously, as you can see, STX as latitude, STY as, longitude first and then latitude. So whatever you alias them, you just got to tell it, what your alias is here. And the metric field in this case, I'm going to put as color because that's what I want to differentiate my different buses. Okay, now that we've basically configured the data, we've told Grafana how our output is being configured. Now we configure the visuals. So the one thing that I'm going to do here is just select a custom center of the map. So I did some research beforehand and found a place in North America that would be a good vantage point for looking at the buses in New York. This is just off the coast, the East Coast in the USA. You can also choose one of the presets values such as like North America or something, if you're looking at something on a more global scale. And then we want to play with this thing called the initial zoom. So this will zoom us in from this global view that we have going on. I'm going to choose 11, could choose 12. Let's see whether it takes us maybe too much in. Let's do 11. So you can see as I scroll down a little bit on the map, I am seeing a lot of big circles. These currently are representing my buses. So these circles are really big right now. So what I'm going to do is select this min circle size to be 2 and the max circle size to be 1. And that should change, hopefully. As you can see that the circles became a lot smaller. And then what I'm going to use here is I'm going to show this legend and use a mouse wheel to zoom. This is just so that you can like zoom in and out with your mouse. And then what we're going to do is color the buses according to the colors that we've assigned them. So remember in the previous step, we have these colors 1, 2, 3, and 4. This is going to be like a hack of the Grafana thresholds options. So I'm just going to set thresholds 1, 2, 3, and 4. And what will happen now is I'm going to assign colors to these different numbers. So say for buses that are less than 1, I'm going to keep it red because these buses are not the ones we want to look at. Then for 1, I'm going to assign it blue. For 2, I'm going to assign it yellow. For 3, I'm going to assign it purple. And for 4, I'll keep it as green. And as you can see, as I selected these threshold colors, the buses, based on whether their value, based on their color value, get colored accordingly on the map. I don't know why these orange things are still there. Maybe if I refresh, they'll go away. Basically, this threshold value, as you can see, this is why I enable the legend. It actually tells you, okay, buses that are colored number 1 are going to be blue, 2 is yellow, 3 is purple, and 4 plus is going to be green. The way the thresholds work in Grafana is that they're inclusive of the lower bound, but exclusive of the upper bound. So that's actually something to keep in mind if you have any trouble with thresholds. That's tripped me up a few times. Okay, so we've actually got this graph down showing us the real-time locations of the buses in New York City. I'm going to call this NYC buses real-time. Won't put a description for now. Save the dashboard and go back to our main dashboard. Okay, so as I refreshed that, the green, not the green, the orange circles went away. And as you can see, I can see the real-time location of my buses right now based on the colors. But this is where we're going to use some variables to actually make this visualization even better. I want to make this more interactive because right now I can basically zoom. What if I only want to see buses of a particular type? Say I'm doing some investigations and I only want to monitor buses of a certain type. Right now I have to go into my SQL code and modify, put in the where statement over here to filter out buses of this type. And if I want to monitor a different type later, then I need to change it. So what I'm going to do is use this feature in Grafana called variables in order to help me make this dashboard a bit more interactive. So what I just did there, sorry, that was a bit quick. I'm going to dashboard settings and gone to variables, and I'm going to add a new variable that shows the different routes that are able to be picked from the bus routes that we have. So labels in Grafana, not labels, variables in Grafana work just like variables in other programming languages. You just define a variable and then you can reference it in your queries. So what I'm going to do here is call this variable route because that's the thing that it's about. And then under the label, you can actually give it a real human readable name so that when you're selecting it in the dashboard, you can actually see, okay, this is about New York City bus routes. Okay, that I know what I'm selecting. This is important, especially if you're in a monitoring context or something. You want to stay away from symbols and give human readable names where possible. Then we're going to select the data source. I'm going to select MTA bus DB. This is cool. And the other thing is that the query, the type of the variable is going to be query. These are cool if you want to actually populate your variables based on a query returned from some database. in this case, I'm going to define this query showing the different types of buses that I have. So in this case, what I'm doing is actually, this is a hack that I learned from a teammate of mine at Timescale, who actually used to be a Grafana contributor. And he basically said, a way to do this is you want to have both symbols, in this case, M, B, Q, and S, because that's actually the values that I'm using in my query. But I also want human readable names. In this case, Manhattan, Bronx, and Brooklyn. This is what M, B, and S stand for. So the hack around it is you don't just select the symbols, but you define these key and values. So in this case, I have K being text, and I have V being a value, and I've defined these key value pairs under the values in this values set over here. And then at the end, I basically say, okay, the way that my values are set up is key first and then the value. And then you can see over here at the bottom, the preview of the values I'm getting are actually the human readable names, but they correspond to M, B, Q, and S. And you can see how that comes together a bit later in our query. In the selection options, what I'm going to do is select multi-value, because I might want to monitor multiple of these bus routes at the same time. And I'm going to include an all option such that all of them are selected. I'm not going to use this experimental feature for now. We might do it in another webinar. But you can actually see these are the values that I'm going to select because I want to know these different routes. And I'm going to select add, and I have my variable right here. Now, right now, you can see our bus, the variable we can select. But if we select stuff, it doesn't really change anything. So let's actually modify our query to make use of this new variable that we've just introduced here. So what I'm going to do here is, because I'm using Postgres and Timescale, the way that we make use of these variables is in the where clause of our SQL statements. So what I'm going to do here is, in the where clause, I've added this statement that says, okay, if the substring of the root ID, if the first letter of the root ID, substring 11, is basically saying start at the first letter, stop at the first letter, is in the set of allowed routes defined by this route variable. Remember, we defined route as being these groups of key value pairs. So I want to know if the first letter is in the set, then show it on the map. And you can see, voila, I've shown Manhattan over here, and I can only see buses that are from Manhattan right now, which are blue. If I expand this allowed set, so this set right now just says Manhattan. If I expand it to Bronx and Queens as well, then those buses will start to show up. So essentially, I've just shown you how to make your dashboards interactive. So it's a really good way you can have variables for different things. And in this case, I can also select the all one, and that shows me all the buses that are going on right now. That's just an include all option. Okay, so we have successfully created this bus monitoring visualization using variables. And as you can see, this variable also shows up at the top in your dashboard. You don't have to just go to the panel to look at it. And you can select, which variables you want, and your queries will actually change in real time, and your visuals will actually update as well. This is good because if you're making dashboard for different stakeholders, you can actually help them to explore without you modifying the code over and over again. This saves a lot of time, and it saved me a lot of time as well. Okay, so that takes us to the end of the geospatial dataset and the IoT dataset. The final thing in our demo that we're going to do today is going to be using this public dataset of monitoring COVID-19. I've gotten this data from the New York Times. And what we're going to do is build this really quick visualization of the total cases and total deaths, but using this hack of using two y-axes in a time series graph. Okay, so let's get started on that. So, one of the reasons why I chose this is because Grafana is open source, and so it makes it really great for using public data sets with, because you don't have to pay to use it or anything. And in this case, the query that I'm going to use, so first of all, I'm going to select graph because that's what I want. And then the query that I'm going to the database that I'm querying is called the COVID-19 data. And the last thing I'm going to do is just write the query in. That's going to just, it's a very, very simple SQL query. I'm just selecting the time, the sum of the total cases, and I'm calling that total cases, and the sum of the total deaths as total deaths from the states table. So I have basically a table showing data by states, group by time, and order by time. Very simple. You notice here I get this data outside time range thing because my current time range is set to 15 minutes. Let me set that to 30 days. And I actually get this graph that shows me the total cases and the total deaths according to COVID in the USA, according to the New York Times, sorry, from COVID-19 in the USA. And you can see how that changes over time. Now, the issue here is, if you see this in a newspaper, some people might look at this graph and say, okay, this cases are increasing over time rather, but the deaths, they're looking fairly flat. Maybe this thing is not that serious. Maybe they haven't, read the other information about, what's going on. And so this graph can be a little bit misleading in terms of the growth rate of these two different variables. And that's because of the fact that they're being plotted on the same y-axis over here. And the scale of this total cases is actually distorting how you can see the growth rate of the total deaths going on here. So we're going to fix this by doing something called a series override in Grafana. So I'm going to click Add Series Override, and I'm going to select the alias, and the aliases that you defined will pop up. So in this case, I'm going to select total deaths. And in this case, I'm going to basically create another y-axis. So I'm going to scroll down to y-axis and select y-axis 2. And then you can already see that, okay, I have a second y-axis right now. And this y-axis actually, because I've plotted total cases using the left y-axis and total deaths using the right y-axis, I can actually see, okay, now total deaths are actually growing a lot more than I initially thought when I actually plot it on an axis that shows me the accurate scale. So in this case, what I'm going to also do is modify this visual to make it, look a bit more useful and make it more useful for people looking at it. So I have the actual data points if you want to look at data on a certain day. And then what I'm also going to do is change the colors of the series. So in this case, if you just click on the color, I can select total cases as being yellow. And then I'm going to select, again, clicking on the color, total deaths as being red. And in this case, I've actually plotted these two quantities on the same graph. They're being selected in the same query, but I can actually have them correspond to different y-axes. And that's super important, especially when you're dealing with two quantities that are just different magnitude of values. This can be a super useful trick to making sure that the growth rates stay in perspective. So I'm going to call this COVID-19 spread in the USA and COVID-19 in the USA, and I'm going to save that. And that's how you can also, we built this line graph over here, but that's actually in a more advanced version of if you're plotting two series on the same graph and you want to use different axes in order to keep things in better perspective and make these graphs more accurate in terms of the people looking at them, more easily comprehending the growth rates. Okay, so that brings us to the end of this demo. Thank you so much for joining us for today's webinar. Hopefully you learned quite a bit. I've taken you through these three different data sets. I'm going to do very quickly, just give you a recap of what we've talked about and leave you with some next steps and resources that you can get started on your own. Okay, so what do we talk about today? We looked at why should you use Grafana. I talked about how it's low cost, support for a variety of different visuals and data sources. I showed you how to set up a Grafana data source, that one being Timescale. We built 6 different visualizations for 3 different scenarios, DevOps, IoT, and geospatial data, as well as a public data set of tracking COVID-19. And we built things like a single stat, a gauge, a graph, and a world map. And then lastly, I showed you some pro tips using variables, series override, and threshold to make your graphs more usable and get more value out of them. That's what we did today. Hopefully you found a lot of value out of it. As a next step, check out the Grafana tutorial that we put together, which is basically what I showed you here, but in document form. It takes you to step-by-step all the queries that we used. The next thing that you can do is join the Timescale developer Slack. If you have any issues, any problems, there's a community of developers, not just people like me who work at Timescale or the Timescale founders, but also other Timescale users who help each other out if they face any problems. And thirdly, if you're looking for a way to get started with Timescale and you don't want to manage and you don't want to host it, please start a free Timescale cloud trial. We're giving you $300 in credits to start. And then lastly, if you're inspired by anything that I covered today, and if you incorporate any of the knowledge, it'll be cool if you can share it with us to let us know that you're using this stuff. Share your creations on Twitter using the hashtag #MyTimescaleDashboard. Hopefully we'll get a few of you doing that. Lastly, I'm just going to put some bonus resources here, just related to some of the things that I covered in the demo. So the first one is the first use case that I said it was in the DevOps use case. That was using this Prometheus connector that Timescale has developed. We've put out two things that you can follow up if you're a DevOps, if you have a DevOps use case. The first one is the observability design doc, where we're actually taking public comments on our new Prometheus connector. And then the second one, is Helm charts that you can then go test out and start using in this GitHub repo that's linked here. And then if you enjoyed the public data part of today's demo, we actually host a virtual meetup called DataPub. It's all about public data. And that happens on the third Tuesday of every month. You can go to this link to sign up for the next one. And then I've left some links to the JSON of the demo dashboard that I put together. So this dashboard that I just created right now, you can actually get the finished version as a JSON. In JSON, you can just copy and paste that into a new Grafana dashboard and start. You don't have to necessarily follow along. And then I've left you a link to Grafana community dashboards that you can also use. And then lastly, just an appendix on inner joins. If anyone was confused about that, you can come and take a look at it. And that brings us to the end of today's session. Thank you so much for joining us. Hopefully you learned a lot, and I'm gonna take your questions now in the Q&A part, in the Q&A panel. So thank you again, and do put your questions if you haven't yet, and we'll answer them one by one.